This video is going to cover adding and subtracting decimals. Okay, this is a process that we're going to be using the algorithm to do, but it's really important to make sure that we're always lining up our place value no matter what problem we're working on. Okay, as long as you line up your place value, this process is not actually very difficult. Okay. For the first problem, we're going to be working on 1 and 23 hundredths, and we're going to be adding 5 and 89 hundredths to it. Before we do any problem, okay, and this is required, if you do not do this on quizzes or tests, you will get the problems wrong. You must estimate. And that is just one of my pet peeves. You have to estimate before you work on any of these decimal problems, okay? Well, the way we want to estimate is I look at each of these numbers and I try to change this problem into something that I could do without an algorithm. So I know if I turned 1 and 23 hundredths and I rounded it to the nearest whole number, which is 1, and I took 5 and 89 hundredths and I rounded that to the nearest whole number, which is 6, and I added them together, my answer to this problem should be about 7. So this is our way to kind of check the problem without having to use a calculator to actually check it. Okay, so step 1, always have to estimate. Okay, this is their big warning. Have to estimate always. So as we go back to the problem, if we're adding 1 and 23 hundredths and 5 and 89 hundredths, just like we're adding whole numbers, we have to line up place value. So in the first problem, and I'm going to put some lines down here to kind of help me line up at first, but I won't for most of the problems after this. So if I'm going to write in 1 and 23 hundredths, and I'm going to add 5 and 89 hundredths, and I am going to add them together like this. Now, you're going to frequently hear people say, line up the decimal point. Well, lining up the decimal point should be lining up the place value as well. So they make sense both ways, but I will frequently say lining up place value. So in the hundredths place, we have a 3 and a 9. And we add them together, and we actually get 12 hundredths, which is the same as 1/10 and 2 hundredths. So I'm going to put my 2 hundredths there, and I'm going to add my extra tenth up top. So I have 1/10 plus 2 tenths plus 8 tenths. That's going to be 11 tenths, or 1 whole and 1/10 left over. So I put my 1 whole back up there, and I go 1 plus 1 plus 5 is 7. Now, because I lined up my decimal point goes right down there, but this is also the other thing. If we look at our estimation with 7, we're going to ask ourselves, where would the decimal point go in this problem to be closest to our estimation? Well, then it has to go right there. So our answer is 7 and 12 hundredths, which is incredibly close to our estimation, which means our answer to this problem is correct. This gets a little bit harder, but the process is going to stay generally the same. But step 1, as always, is we must estimate. Once again, I'm going to round these to the nearest whole number. So this turns into 62 minus, that's about 6. Well, 62 minus 2 is 60. So then we go 4 more left of 60, and we end up with 56 as our estimation. So our answer to this problem should be close to 56. Okay? So once again, I'm going to line up the place values. So I have 62 and 3 tenths. And this is 5 ones, so that has to go in the ones place. And then 853 thousandths. Now, the problem here is that the first part of the problem we want to subtract in the hundredths or the thousandths column, and there is no number there. So we're going to change 62 and 3 tenths into 62 and 300 thousandths. We can add those zeros by multiplying that number by 100. Okay, so we have 62 and 300 thousandths minus 5 and 853 thousandths. Okay, so we are going to have to do a lot of borrowing in this problem, but we have done that before. So that turns into a 9, because it'll be 10, and then we'll cut it down to 9, and this turns into a 10. So in the thousandths place, we have 7 thousandths. In the hundredths place, we have 9 minus 5. So we get 4 in the hundredths place. We're going to have to borrow again here. It's almost like a math teacher made this problem here. So 12 tenths minus 8 tenths gives us 4 tenths. Here, we have to borrow again. So then we have 11 ones minus 5 ones gives us 6. And then this is a 0 here, so 5 minus 0 is 5. And if you look, we have 56 and 447 thousandths. Gets a little tough to say. And that is very close to our estimation. So once again, we are correct. So this right here, this is about as tough as these problems will get. As long as you're good at lining up your place value and watching your borrowing, and you always estimate, your problems won't do too bad at all. So let's do one story problem here. So the Minnesota Timberwolves, which the person who made this problem called them the greatest basketball team ever created. So since it's in writing, it has to be true. So the Minnesota Timberwolves, which is the greatest basketball team ever created, has 3 high-scoring players. Karl Anthony Towns averages 26 and 3/10 points per game. Andrew Wiggins scores 21 and 22/100 points per game. And Zach LaVine scores 15 points per game. How much do these players average together each game? So one of the things that I like to do in story problems is I like to circle the important information. So we have 26 and 3/10 points per game. We have 21 and 22/100 points per game. And then we have 15 points per game. So everything else here is basically junk. We want those 3 numbers. And then in the question, how much do these players average together per game? So the keyword here is together. Together means addition. So we are going to be adding these numbers up. So we have 26 and 3/10 plus 21 and 22/100 plus 15. So let's do our estimation, which is 26 plus 21 plus 15. These two average to be 47. 47 plus 15, well, that's going to be 52 plus 10, so 62 is our estimation. And now we're just going to simply line up the place value and add them together. So we have 26 and 3/10, 21 and 22/100. So I'm going to change that into 30/100 there, and then 15. And we're going to do 15 and 0/100. So really, if one number is in hundredths, the others have to be in hundredths as well. So when I add them together, in the hundredths column, 0 plus 2 plus 0 is 2/100. In the tenths column, 3/10 plus 2/10 plus 0 is 5/10. Our decimal point comes right down. In the ones column, we have 6 plus 1 plus 5, which is 12. So we bring our 110 up here. And then 1 plus 2 is 3, plus 2 more is 5, plus 1 more is 62 and 52/100. And since this is a story problem, we have to write this out as a sentence, okay? So these players average 62 and 52/100 points per game together. And there we go. That is about as difficult as these problems will get. Once again, as always, if you have questions, please let me know as soon as possible.